Since September 2003, 76 schools in England and Wales have been piloting a new GCSE, 21st Century Science. At Haggerston School in East London, 180 girls are studying the new course, and it's been a popular move. In part 2, we now discover why the pilot was commissioned, evaluate its success, and the importance of scientific literacy in society today.
I think now we're in the 21st century where science is central to our lives as never before. The notion of scientific literacy is very important. It's very important in education. In my day, we'd learn about the amoeba or how to distill water, and no one bothered telling me why distilling water was interesting. And even more worrying was why the life of the amoeba was of any relevance to me whatsoever. It was completely disembodied. If one is studying instead the issues of mobile phones, genetically modified foods, notions of risk, for example, how come we can say, I won't eat GM foods until someone proves they're safe, but I will use my mobile phone until someone proves it's dangerous? That's quite an interesting topic to discuss and evaluate. And I think the more we can persuade people that science is relevant to everyday life, the more engaged they'll be with it.
What makes a volcano blow up? Is it going to blow up? And if it does, what's going to happen? Maybe people want to sit in their house anyway with ash. How are you predicting?
Since the time they brought in double science with the national curriculum in 1989, science has tried to meet the needs of everybody. And I don't think the double science option that was there, as was, actually achieves that. I think that there are some students who want to be scientists. There are some students, and that's very, very far from their mind. It's very difficult to see how one double science course could meet that aim. That's one side of it. So I think it gives, there's an element of choice in this new way of studying.
What exact possibility is there? Come on, you're a top scientist.
You know, when they predict the weather forecast, they say that it might be raining or windy because they have the satellites and everything, and that's what they're telling them. But sometimes they are right, but they can't always be 100% certain, and sometimes it is wrong.
Does that mean they were rubbish scientists and a good scientist would have got it right?
No. You can't be always...
In 1998, the Beyond 2000 report from King's College London made major recommendations for changes to science education. The Qualifications and Curriculum Authority commissioned the University of York Science Education Group to develop an alternative model for GCSE science. How did the 21st Century Science team tackle the problem?
The first recommendation of that report was that compulsory science education should be to develop scientific literacy. It should be general education for everybody to meet their needs as future citizens, and that there should be a single science course to do that. And then separately there should be appropriate science for scientists courses. And in our pilot we're experimenting with two models of science for scientists. One is more conceptual, more obviously a preparation for A-level physics, chemistry, biology and so on. And the other, which we call applied, is more technical problem solving to do with the practical applications of science in our lives.
In part 1, we saw the three courses in action. What are their aims?
The core science course looks at science from the point of view of the consumer or the citizen. It's the science that comes up in everyday life, or that lies behind things that we encounter in everyday life, but also, for example, making a decision about whether to immunize your child. But there's also another kind of science that informs everyday life, which is science about who we are and where we are, and so big questions about our place in the universe and what the history of life on Earth is and so on. The awful thing is that until we started to work at it, those sorts of things were largely absent from science courses in schools.
Ozone, good. Can you remember the formula of it? It's a secondary pollutant, very good. Secondary, well done.
It's difficult to get the balance right with core science in that the primary interest is not the science itself, but enough science to be able to understand an issue. So, for example, what should we do about radioactive wastes? Well, you need to understand that they give off emissions which are hazardous, that the rate at which they give them off falls with time. But there's a question about how much nuclear physics you have to understand.
So everybody in this room will have a different DNA. Where do we find DNA?
The applied course takes a different perspective. It takes the perspective of the practitioner who's using science perhaps peripherally in their work. A whole range of practitioners from technician level up to a professional level, but not scientists as such, but those who use science in their work. So one of our modules is on life care, and there are a whole range of healthcare practitioners.
Squeeze, put it in, and release. Excellent. Now take it out. Very good. Yeah, place it
I think the
upside down.
key thing about the applied course is that it can be rewarding even for foundation tier students. The hands-on practical competence in contexts where the results matter. The pilot is showing that young people are really enjoying doing that, and the students can then use what they learn in problem-solving activities.
The general course is meant to lead through concepts and offers an intellectual challenge and the pleasure of understanding things for those who enjoy an intellectual challenge.
Power?
A bit louder.
Power.
Louder than that.
Power!
What did she say, Geraldine?
It's meant for those who decide to, it's meant to also provide them a good foundation for post-16 study in sciences. So it strips away a lot of context and it really focuses on the scientific ideas and the pleasure of developing and understanding those.
Andrew Hunt and Peter Campbell spent a day at Haggerston School to see how the pilot was progressing.
Before, it wasn't just mixed ability, it was mixed attitude. It was made very clear what the two courses were, and every person in this room has chosen to be here. Whereas before you got people, why are we working out the current? They know that, like, one, because that's part of science, but two, it is an intellectual challenge for them that they like. They are the type of people who like intellectual challenge.
I enjoyed the general class, and it seemed to me that the teacher really threw himself into it, and his whole self was there, and he was then able to get the girls to throw their whole selves into it as well.
What's this say on it, Danielle?
It says 2 times 32 what?
All right, bingo beats.
One of the things that I was really pleased about was how different the general and the core classes were, because part of our whole idea is that one of the weaknesses of the current national curriculum is that double science is just more of the same, and that what we're offering is more that is contrasty.
What I don't think is working very well is that the foundation higher work needs to be differentiated more, and some of the activities the foundation pupils or the less able pupils find it quite challenging.
We have not catered as well as we must for those students doing foundation tier, particularly in the core, because it's absolutely crucial that the core course works for everybody.
Some of the core modules need to have more practical work in them because it's all quite a lot of discussion and research, but not much practical. And we're okay at a girls' school, but I think at a boys' school they're going to get very, very restless.
The whole scheme got a reputation for being a bit light on practical work because in the pilot the first 3 modules of the core course are indeed light on practical work. And of course that's what everybody taught first. And one of the things we're doing is rearranging the order of the modules so that the practical work that there is more appropriately spread.
I think the teachers need a lot more training because it's a very different way of teaching, and some teachers aren't au fait with group work and they might be feeling a little bit lost.
The students seem to be fairly motivated. Very few students are actually asking me what's the point in doing this in the core. They do really like the applied course because they like the extent of the practical work that they're doing there. But they also have actually found the discussion work and the other contexts that they're using in the core quite motivating. And I think, you know, they do, for example, take out your mobile phone and work out is it damaging your health is much more motivating than just trying to learn what aspects of the electromagnetic spectrum are and what they could be used for.
The girls like it, the teachers like it, and already our results are going sky high. So it's everything that the head of faculty promised me, motivational, inspiring the girls, and they're interested in science.
I like being involved in group work, and applied is involved with teamwork, and you do quite a lot of practical, so that's an advantage for me, and also you get marked for it.
If we'd done this in the old exams with EdXL, then we wouldn't have been going into this much detail about kilowatt hours, energy in the home and stuff like that.
I think it's really good because it applies to the modern world today, like issues such as cloning, we can refer that to today, and DNA testing, which wasn't available back then when some of the other books were written.
I think it's really good. It is a big change that we get to sit modular exams instead of having to sit one big exam in the end, because I usually struggle with science.
We started off with 80 pilot schools. We've completed the first year. If it had gone really badly, I imagine that quite a lot of the pilot schools would have said, well, we'll see it through for the first cohort, but then we're dropping out. Well, they're not dropping out. In fact, the reverse. When we ring the pilot centres and ask them what's going on, we find that those that put a toe in the water last year, they're really wading in and putting in more students. So we've kept the pilot schools and they're committing more strongly to the project.
I would say 21st century science, it is the way forward, but it's not necessarily the destination. I entirely accept that science is a compulsory subject for every student in this country to do, and before it was utterly irrelevant to 90% of them, and 10% got it and got a lot out of it, and we've then changed it for those 90%, and I don't know if it's silly to, I slightly worry about those 10%.
If we can introduce more vocational GCSEs with a work-related element to them, we believe that this will help our girls to become better qualified for the world of work and to, in fact, act as better citizens in the future. It's about using motivation to improve knowledge, to improve understanding. It's about learning how to become a lifelong learner, and vocational GCSEs, we think, and a number of us think, are the way forward.
The key point is that all GCSEs change from September 2006. It's crucial to understand that it's not compulsory, but the fact is there will be choice and nobody will be made to do 21st century science, and that's the way we want it to be.